Okay, I'm given the parametric equations of a graph, and I want to show it's a straight line. Well, I know that straight lines from GCSE, I know that straight lines look like y equals mx plus c, but this is a Cartesian equation. In other words, m and c are known numbers. This just involves y and x as the variables. They don't have this t in. So what I'm going to do is I'm going to lob these parametric equations into a Cartesian equation. Now, in the simplest case, and this is pretty much as simple as it gets, we can make t the subject of one formula and substitute it into the other. And since I'm going to want y as the subject of the formula, let's make t the subject of the x formula. So x equals 2t plus 1 gives me that 2t equals x minus 1. So t equals, I could put x minus 1 over 2, but I think half brackets x minus 1 is going to be even nicer. Okay, now I know what t is from one equation, I substitute it into the other equation. So y is going to equal 3 times t, and t is a half brackets x minus 1, minus 2 at the end. Okay, now if I was going for simplicity, I'd probably multiply by this too, but I want y equals mx plus c. So let's just multiply this out. So this is 3 over 2, so y equals 3 over 2 times x is 3 over 2 x. And then I've got 3 over 2 times minus 1. So that's going to be minus 3 over 2 minus 2, so y equals 3 over 2x, and this is another 4 over 2, so that's minus 7 over 2. Okay, so therefore I can just comment that that is a straight line. That's one of the things I had to do. I had to show that it's a straight line, so I must draw that conclusion. And the other thing I needed to find was its gradient, so I need to say for this line that m, the gradient, is the number in front of x, 3 over 2. So that's that question. Okay, so let's look at a slightly harder one. So here, again, I've got parametric equations with t, and I want a Cartesian equation. That means it's just allowed to have x and y in it. But on this occasion, rearranging one to make t the subject and then substituting into the other is going to be pretty unpleasant because t appears twice here. This is actually rearrangeable into a quadratic equation in t. I don't want to go there. All right. What I can notice, though, is that x and y are very similar. So x and y just have this sign swap. So what I can do is I can treat this a little bit like simultaneous equations, and I can very easily eliminate this 1 over t. So if I do that, if I do the equation for x plus the equation for y, obviously I'm going to get x plus y. But if I add this expression for x to this expression for y, I'm going to get t plus 1 over t plus t minus 1 over t, and that just equals 2t, because this cancels with this. So I now know what 2t is, so therefore t equals a half brackets x plus y. How does that help? Well, I can now get a Cartesian equation. From either of these, let's take the y one. Okay, y is going to equal t, which is a half brackets x plus y, minus 1 over t, so that's 1 over a half brackets x plus y. And that is the Cartesian equation. I mean, I probably should simplify this a little bit. So let's do that. Let's multiply both sides by a half brackets x plus y, just to eliminate this fraction. So I'm going to end up with minus 1 over here. So on this side, I'm going to end up with a half brackets x plus y times the y that's already here. But I mustn't forget to multiply this term by a half brackets x plus y. So I'm going to get a half times a half, which is a quarter. And I'm going to get x plus y times itself, so that's x plus y squared. And okay, it's beginning to look a little bit simpler. I think I'm going to have to multiply everything out. But the other thing I want to do is let's get rid of the fractions. So let's multiply by 4. So this a half times 4 is going to be 2. And then if I multiply this bracket by the y, I'm going to get an xy plus y squared equals, well, I've multiplied by the 4, by 4, so the quarter's going. So this is just x plus y in a bracket squared, which is x squared plus 2xy plus y squared. Don't forget, this is a bracket squared. You have to square it out properly. You can't just square the x and square the y. And then I need to multiply the minus 1 by, I've multiplied everything through by 4, if you remember. So this is going to become minus 4. So, I've got 2xy here, but that's going to cancel with the 2xy there. So this was a good thing to do. And I've got a 2y squared here. I've just got 1y squared here. So if I subtract y squared, let's get 0 on the right hand side. So I'm taking y squared away from 2y squared, so I'm going to get y squared. And I'm taking away this x squared, because I want to get 0 here. And I'm adding this 4, because I want to get 0 on that side. So there's my equation, y squared minus x squared plus 4 equals 0. And I'm done.